At the end of the last video, we briefly discussed the standard form of the equation of a circle. The equation of a circle is in standard form if it's written with everything multiplied out. We have an x squared term and a y squared term which have the same coefficients, and those coefficients are positive. Then we have an x term and a y term and a constant term. All of the coefficients are integers, and again, we've arranged things so that the x squared term and the y squared term are both positive. If they're both negative, we multiply both sides by -1. So that's standard form. We now have two different forms for the equation of a circle. And as always happens when we have two different forms for something, we'd like to be able to translate between them. Now, going from the center radius form to the standard form is pretty straightforward. Here we'd like to write the equation of a circle with a certain center and a certain radius in standard form. Our first step is to write down the center radius form. That'll be x minus, the x-coordinate of our center is -2, so x plus 2 squared, plus y minus, the y-coordinate of our center is a 5, so y minus 5 squared, equals our radius squared, 7 squared. So now that we have our equation, we can rearrange it to be in standard form. Our next step is to multiply everything out. So x plus 2 squared, that's x squared plus 4x plus 4. Y minus 5 squared, that's y squared minus 10y plus 25. And that's all equal to 7 squared is 49. Okay, so now we've squared everything that's squared. Those parentheses on the left are not doing anything for us in this example. It's a good habit to be in to include those when you're multiplying out within a larger expression. But in this case, they aren't doing anything, so we can ignore them. What we do want to do is arrange the terms in the proper order. So I'm going to put my x squared term, and then my y squared term, and then my x term, and then my y term, and then let's see, I've got a plus 4 and a plus 25, and that equals 49. Combining the 4 and the 25, we'll have x squared plus y squared plus 4x minus 10y plus 29 equals 49. And finally, we'll subtract the 49 on both sides, and we'll have x squared plus y squared plus 4x minus 10y minus 20 equals 0. Notice, in the notation above, we have a equals 1, c equals 4, d equals -10, and f equals -20. In general, you will not need to keep track of those symbols. At this point, we're just noting that we fit that form. So here is our equation in standard form. Now, notice, when we put that equation into standard form, we multiplied out something that was squared. In order to reverse that process, we're going to need to, well, split up all this stuff and figure out what was squared. And this is a job for our favorite process in mathematics, completing the square. So, in this next example, we're given an equation, and we want to put it in center radius form. And then we're going to actually draw the circle. So to get into center radius form, our first step is to get rid of those coefficients on x squared and y squared. This is why they need to have the same coefficient if we're going to play this game. If they have different coefficients, we're going to get stuck at this point. So we're going to divide every term by 4, and we'll have x squared plus y squared minus 6x plus 2y plus 15/4 equals 0. Okay, now we want to arrange the terms so that we're ready to complete the square. That's going to involve two things. That's going to involve putting the x terms together with space for a constant, the y terms together with space for a constant, and then moving the constant to the other side of the equation. So my x terms first. I have an x squared minus 6x. I'll write those first. X squared minus 6x plus something. I'm going to need a constant there, and I'll figure that out in a minute. Plus, here are my y terms, y squared and 2y. So y squared plus 2y plus another constant that I'll figure out in a minute. And then my 15/4, I'll subtract that from both sides to give me negative 15/4. And then whatever those two constants are that I'm coming up with, I'll need to add those to the right-hand side as well. Okay. So I'm going to complete the square twice. So I've got an x squared and a minus 6x that I'm splitting in half. So I'll have an x squared and 2 minus 3x's. That'll be an x times an x, negative 3 and negative 3. So my constant that I need to add is 9. If I add a 9 here, I'll also need to add a 9 here. Completing the square for the second part. For the y's now, I have a y squared. I have a 2y I need to split in half, so I'll have a 1y here and a 1y here. I've got a y and a y. This is y times 1, y times 1. So these are both going to be plus 1. And then 1 times 1 is 1. That's the constant I need here. And if I add a 1 on the left, I need to add a 1 on the right. So this is just the same completing the square that I've done before. I just need to do it twice, once in the x terms and once in the y terms. Then my x part of my equation becomes x minus 3 squared. My y part of my equation becomes y plus 1 squared. And on the right-hand side, I'm going to just throw all of that into a calculator. I get 25/4, which is 5/2 squared. My center is at, well, h is 3. K is plus 1 is the same as minus negative 1. So K is negative 1. Here's my center at 3, negative 1. And my radius is 5/2. So my axes here are set up with a tick mark every half. So I'm going to count 5 of these up, 5 to the right, 5 down, 5 to the left. And now I'm going to draw the circle through those points. And this is what we do whenever we want to graph a circle that we've encountered in standard form. We rewrite it in center radius form by completing the square. And using that, we can find our center and radius and draw our circle.